Balloon class. Sorry I'm absent again. I should be back tomorrow. My daughter's doing much better. She'll be back at school tomorrow, but I've still got a fever. But I have no pox yet, so that's a good thing. Anyways, let's get you guys started on circles. I'd like to do some work with you on circles, so let's just do some background work before we get started tomorrow, hopefully. Alright, so your homework tonight is Central Angles Worksheet. I'm going to actually just do problems right off of it, about 7 of them with you, and then let you finish doing it in class today. Alright, so let's talk about circle basics from yesterday. So the area inside the blue chain is known as the area of the circle. This is pretty basic. The length of the path along the blue chain is the circumference of the circle. So all the way around is the circumference. And most of you should know that if you go all the way around in a circle, that's 360 degrees. Let's see, the line all the way across, let's change it to green. Area all the way across right here would be my diameter. And of course my center is in the middle. And then my radius. What color do we want to make the radius? How about pink? So here's my radius. Radius is also, I could have several radii inside of a circle, including half that diameter. Alright, that's what I meant here. Radius here. Okay, so let's move on to some of the newer vocabulary that you learned yesterday. So we have the diameter going all the way across. We also have a chord. The chord is just, actually you can look at it like the diameter is just a chord that goes through the center of a circle. A secant is an actual line. It's like the chord, but it extends through the circle. So it's a line that intersects the circle at 2 points. Right here and right here. And then the difference between a secant and a tangent is a tangent only intersects at the point of tangency, or just right on the very edge of the circle. It's only touching it in one spot. Alright, so today we're going to talk about the central angle. So the central angle is an angle whose vertex is at the center and whose sides are radii of that circle. So this is a radius, this is a radius, and together with their vertex angle, this makes your central angle. What's really interesting about the central angle is the measure of the central angle equals the measure of the intercepted arc. Alright, let's talk about what an arc is. An arc, I'm actually going to use my highlighter on this one. This would be the intercepted arc right here. I'm going to try and make that look as nice as possible. This would be the intercepted arc. Intercepted because the angle is intercepting right here. We could call that point A. And right here, we could call that point B. And I'm just going to pick somewhere else on the other side of my circle. How about right here, right on the diameter? We'll call that one C. Actually, just to change things up here, I'm going to make 2 points. C and D. So arc AB, written like this, would be my minor arc, or just my arc. there's another arc. So if I have a minor arc, I'm also going to have a major arc. And the major arc is the arc that's surrounding the entire minor arc. So there's a couple different ways we could write this major arc. We could write the major arc as being B, C, A. Major arcs always have 3 letters. That's how you know they're major. Or I could have called it B, D, A, but it has to go in order. I could have called it A, D, not C, because that doesn't go all the way around. It would have to be A, D, all the way over D, A, C, C, or A, C, C. All of those would be acceptable, as long as it goes all the way around until it comes back to where we have our intersections here. Fantastic. So it's really interesting that this angle right here is the same measure as my arc. And it kind of makes sense if you think about it, because if I were to create the circle, and I were to just keep opening this up and opening this up and opening this up, I would eventually get all the way around with 360 degrees. Let's try and do a visual with that. Let's see, might as well use dash circle. So that angle is going to be the same here, and the same here, and the same here, and the same here, all the way out until I reach the outer part of my circle. That kind of makes sense why the central angle is the same measure as the intercepted arc. Erase that. Okay, so here's the answer bank for your worksheet. So go ahead and pause the video and write down these numbers on your worksheet. These are going to be for numbers 9 through 18. Okay, let's get started with number 1. So in number 1 on your worksheet, it says name the arc made by the given angle. So I've got to name this arc. Rather helpfully. Alright, so if they're talking about the angle UQV, UQV, that's this angle right here, and I need to name the arc made by that given angle, my arc starts here. Here's the arc that's associated with that angle. So that was the arc, and usually it starts with the same thing that the angle does, UV. So go ahead and copy that down in your notes. Okay, this one gives me the major arc for angle DQE. It wants to know the major arc. So angle DQE would be DQE. So this angle right here. So DQE has a minor arc. I'm going to change to my highlighter. Has a minor arc here. Well, I don't want the minor arc. I want the major arc. So I need to take the intersection here and here, and I need to go around this circle. So I'm going to start here. I'm going to say D, C, E. This one's a little bit easier because I only have 3 letters to choose from. So the major arc would be E, C, E. Could have also called it E, C, C. So copy that one down on your worksheet. Next one, number 5, says name the central angle of the given arc. Well, if the given arc is WT, then my angle would be W, Q, T. I'm sorry, my central angle. Central angle always comes from the center. So that would be angle W, Q, T. Copy that one down. Next one, number 6. Number 6 asks the same thing. Name the central angle given the arc. Well, this they've given me a major arc. I know it's a major arc because it's got 3 letters. So first I'm going to map out the major arc. I'm going to put it in green because it's the major, not the minor. So D, E, all the way around to G is the major arc. I want the minor arc because that one is going to be associated with the angle that I want. That would be angle D, Q, G. D, Q, G. So copy that one down. Okay, number 10 says find the measure of the arc or central angle indicated. So now I have to find the measure of this arc. Alright, so let's do some investigating here. I've got this arc here. Let me highlight which one I need. I need the measure of the major arc, I, E, G. So I'm looking for I, E, G. All the way around here. I already have 71. I just need all the way around here. Well, luckily, this happens to be a diameter. And a diameter cuts the circle in half. Well, I know it's 360 degrees around a circle. So if I cut in half, or divide it in half, or 2, it's 180 degrees. So this part of the circle I already know is 180 degrees. The green part, I should have done that in blue. We'll do this. So this is 180 degrees. I already know that this is 71 degrees. So that gives me a total of 251 degrees. Alrighty, let's try another one. Number 11. Number 11, let me look at my instructions here. Number 11 says solve for x. Assume that lines which appear to be diameters are actually diameters. Okay, so I have a couple diameters here. I have a diameter here. I have a diameter here. See, it's giving me this angle here, this arc here. Well, if this arc here is 115 degrees, sorry, I should change my color. So if this is 115 degrees, then so is this. Central angle is 115 degrees. Well, I have this value here and this value here. Notice that if I were to combine the two, by combining both arcs, I would have this arc, which is 61x minus 1. And if I wanted to add that to this arc, which is 55, I could actually say that that was equal to this other arc. Does anybody know why? Hopefully somebody gets it, because this angle and this angle are vertical angles, and they're equal. So if this is 115 degrees, then both of these angles added together is 115 degrees. So I can total it to 115. I'm going to change the color though. Alright, so 61x's, -1 and positive 55 is a positive 54. Equals 115. If I subtract 54 from both sides, I get 61. If I divide both sides by 61, I get x equals 1. I could check that. If x is equal to 1, 61 times 1 minus 1 would be 60. And is 60 and 55 115? It is indeed. So we know that we're correct. Check. So copy that one down. I've got one more to do with you, and I'm going to send you off on your own. All right, number 17, same type of problem, solving for x. Okay, this time I've got 180 degrees here, but that's not a vertical angle. What else do I have? I have 45 degrees here. That makes this angle, that makes this angle match that, which is 45. These do look like vertical angles. That makes this one also 45. That makes this arc here 45. Now I'm seeing what's going on here. I've got a diameter. So I've got a 45 plus this arc here is going to give me 180 degrees, because I know that half the way around the circle is 180 degrees. So x plus 143 plus 45 is going to have to equal 180 degrees. Let's see, 143 and 45 would give me x plus 188 equals 180. Subtract 108 from both sides, and I get x equals -8. Let's plug it back in and see what happens. So -8 plus 143 is 135. $135 and 45 make 180. So we're good. So that's all for now. I want you guys just to work on your worksheets together and be productive. Thank you.